Okay, so I'm going to go through how to do Learning Targets 1.4, drawing particle pictures from density information, and 1.6. And I'm going to start with 1.4. I included them together because I'm using the same table for both, but we're going to start right here. So for 1.4, first thing you're going to need to know is the densities of each of these substances that we're looking at. So we're looking at lead, which has a density of 11.34 grams for every centimeter cubed. Zinc, which has a density of 7.14 grams per every centimeter cubed. And aluminum, which has the lowest at 2.70 grams for every centimeter cubed. So if they have a larger density, that means they have a larger amount of mass in the same amount of volume. So each one of these boxes represents same amount of space, so same volume. So we're going to have to show more mass. And we decided that we are going to use larger particles to represent larger masses for each. So this must be the largest. This one's going to be smaller, and make sure it is obvious that your particles are smaller. They don't have to be perfectly ordered, but I want to be able to see that it is definitely less mass. That's 8. And then finally aluminum, 2, 3, 4, 5, 6, 8. They should be touching because it's solid, and we should also see through here that this has the most mass in the space, this has the middlest, and this has the least amount of mass in the space because it has the smallest density. So that's a nice visual representation of density, but we want to be able to do calculations with density as well. In the form of the equation that we always want to use, because it's going to be the easiest to manipulate, is mass equals our density times our volume. Sometimes we just write the letters, but this is what you can always return to solve problems like this. So if we want to know this first question, what is the mass of 21 centimeters cubed of silver? Well, I'm going to solve for this. This is my first unknown. So I'm just going to write M. I know the density because I know the substance. It's silver at 10.5 grams for every centimeter cubed. And then I know the volume is 21 centimeters cubed. So these are going to cancel. We're going to be left with the units of mass, which is grams in this instance. And we're just going to multiply it out. When I multiply those together, I get 220.5 grams. Or 220 if we're going to keep the right number of sig figs. But I'm going to be okay with this one. For this one, we have 885 grams, and I want to know what the volume of this for zinc. Same equation again. It's just this time, this is our question mark that we're going to be solving for. So I'm going to put in what I know. 885 grams equals the density of zinc, which is 7.14 grams per every centimeter cubed, times V. That's what we're going to solve for. And this V, it is multiplied by 7.14 grams per every centimeter cubed. So that means to isolate it, we're going to divide by 7.14 grams per centimeter cubed. Okay? Because these two will cancel. Anything divided by itself is 1, so it becomes 1. Grams over grams, centimeters, 1 over centimeters over 1 over centimeters. These all cancel. We will be left with these units. Grams divided by grams, those will cancel as well. And so we will get our volume is 885 divided by 7.14, or 124 centimeters cubed. I'm looking for this level of work. Start here, input what you know, substitute in, and then solve. And finally, this one, a little bit trickier of a problem. I want to know the density of a substance that has these measurements and this mass. So I first need to find the volume because it's not given to me, and I need to know the density. This is my new question mark here. So the first thing I'll do is multiply these three together because they are the three sides of a regular shape. When I multiply those three together, I get 10,500, and it is centimeters times centimeters times centimeters, so it's 10,500 centimeters cubed. So now I know from this equation my mass, my volume, and I'm going to solve for my density. So my mass is 6,962 grams, which is going to equal my density, which I'm going to solve for, times my volume, which is 10,500 grams, or whoops, centimeters cubed. These are multiplied together, so I must divide both sides by this in order to isolate my density. This will cancel, this will cancel, this will cancel, this will cancel. I will be left with just my density, grams over centimeter cubed. Look at that. That is the units I am looking for. And then I'm going to divide 6,962 by 10,500, and I get 0.66 grams per every centimeter cubed. So that's what we're looking to do. Yeah. Let me know if you have any questions. Hopefully that was helpful.